Hello, geometry. Welcome to 8.5 Problem Solving with Trigonometry. We've really done problem solving throughout these last 3 lessons with trig, with the law of sines, law of cosines. So now we're just going to kind of put it all together in one big section. So one of the things to understand when it comes to trig is what kind of triangle are you dealing with. If you're dealing with a right triangle, then sure, use SO, CA, TOA, right? Sine, cosine, tangent. If it's a non-right triangle, then you have the laws, right? Law of sines, law of cosines. And again, it depends on what your situation is. Are you, angle, side, angle, side, side? So again, you got to know what the formula looks like so you know what information you need to be able to use it. Okay, so example 1, identify angles of elevation and depression. So this is very much a right triangle concept, right? So when you talk about angles of elevation and depression, we are mostly talking about right triangles. So an angle of elevation is formed by a horizontal and a diagonal line of sight. So if we look here, right? If I am a person, this person right here is at the top, okay? They're not going to have an angle of elevation because angle of elevations look up, okay? But this person does, right? So when this person is looking up, they are looking horizontally here and line of sight here to the restaurant. So angle 2 is going to be an angle of elevation. You're looking up. Now, when we talk about an angle of depression, let me use green maybe. An angle of depression is also formed by a horizontal and a line of sight. Oh, I see. So an angle of elevation, object above. So good. So angle of depression, object below. So you're looking down, right? So this person at the restaurant actually does have an angle of depression, right? Angle 1 is the angle of depression formed by a horizontal and a line of sight. But that's not the question. It's angle 2 and 3. So this person right here, angle 3 is the angle of depression formed by a horizontal and a line of sight to the object below, the person below. So angle 3 is an angle of depression. Now let me tell you the big mistake people make. A lot of people, especially with the angle of depressions, they want this angle right here, this angle, to be their angle of depression. This is wrong because this angle is formed by a vertical and a line of sight. There is no mention of vertical lines in this at all. Angles of depression and elevation are formed by horizontals. So make sure that you're using the horizontal, horizontal, not the vertical. Now, another thing to keep in mind is that, and let's use angle 1 and 2 as an example, okay? If you look at angles 1 and 2, both are formed by a horizontal and this common line of sight. You can treat the horizontals as parallel lines and the line of sight as your transversal. Angle 1 and angle 2 are alternate interior angles. They're going to be congruent. So in any picture, your angle of elevation should be congruent to your angle of depression. So sometimes it's more advantageous to use an angle of elevation versus an angle of depression and vice versa. Same thing down here, I'll use pink. Angle 3 and angle 4 will be congruent because they use the horizontals and this line as their transversal. Okay, so a lot of stuff going on there with that picture. All right, so let's see if we can attack a problem involving an angle of elevation or depression. Let's see. All right, so it says for a reverse bungee ride, Reagan stands halfway between 2 vertical posts. 2 bungee cords extend from the top of the post to break its waist at a height 1 meter above the ground. How tall are the vertical posts? So they give us a great picture, right? We need to find x. X is the height of this vertical post. Now, the one thing I will caution you on is x is not the final answer because they want the full height. You can't forget this 1 at the bottom, but that's at the very end, okay? We're going to assume that where this pole hits this 1 meter above, that this is going to be a right angle. So we have a right angle, right? So this is a right triangle problem. 70 degrees is our angle. We know that this 8 is split into 2 congruent segments. So this is 4 and that's 4. And now we can use SOHCAHTOA to solve for x. So, from this 70 degrees, I want to find the opposite. I know the adjacent. Opposite and adjacent is tangent. I'm going to create a tangent equation. Tangent of 70 degrees equals my opposite x over my adjacent 4. This is my problem. To solve for x, I'm going to multiply both sides by 4. Remember, if x was on the bottom, you would switch the tangent of 70 and the x, and you'd end up dividing by the tangent of 70. But here, we're going to multiply by 4. So we're going to type 4 tangent of 70 in the calculator, and that's going to be our x value. And then we'll talk about, again, what that means when we come back to the picture. So let me go to Desmos. Remember that when you access Desmos, you need to click on that wrench first and foremost. Make sure you're in degree mode. So we're doing 4 tangent of 70. And I got 10.98. We're going to go ahead and round that to 11. So our x value is 11. And that would be what? Meters. But again, you're not done. Why are you not done? Let's go back to the picture. So in this picture, that is the value of x, right? So x is 11. But this post goes all the way to the ground, which means you have to add that 1. So the total height of the vertical post is 11 plus 1, which is 12 meters. So that was your angle of elevation. I didn't even talk about angle of elevation, but that's what that is. Angle of elevation, right triangle problem. All right, stay tuned to video 2 where we do a couple non-right triangle problems.